All right, so interval and frequency, int, freq, whatever. All right. Minimum, 0, maximum, less than 20. So this is how we write it. 0, 0, 2, less than 20. That first entry has an n value of 2. All right. I'll snip that one in there. Somewhere. I'm just going to make it small and put it in the margin. Just so when you're looking it over later, you can say, ah, that's where that came from. All right, so 0 to less than 20, there's 2 of them. Then we hit the right arrow. That'll give us our next interval, 20 to less than 40. And there's one of those. Right arrow, 40 to less than 60. Yeah, but also it tells you where it says n equals. It also tells you the number right there.
I didn't see that.
Yeah.
Sense. I just figured it out.
Yeah. So we have n equals 4. And also when we're creating the graph, I'm going to encourage you to write down the n value also, because sometimes it'll look like it's at a certain height based on your graph, but you mean for it to be a different height. I want to be able to give you as much credit as possible. I don't like taking off points. Slows down the grading process. Hit the right arrow, 60 to less than 80. Right arrow, 80 to less than 100. Already forgot the number. 8 of them. 8 of them, wow. And then the last one is 100 to less than 120, and there's 2 of those. All right. So we have our table of values, and honestly, the only time I looked at this raw data set was when I was typing it in. I haven't really considered it ever since. Right? So that's an important piece. You're not really doing any of this work. You're just letting the calculator handle it all, and you're just worried about the interpretation. That's something that is kind of a failing in this world of statistics all through the years, is that different curricula, I don't want to blame individual teachers, but like different methods of conveying the information got too bogged down in just, all right, let's learn this topic, let's learn that topic, let's learn that topic, let's just, here's a formula, here's another formula, and it's like, I hate statistics, it's so boring. It's like, no, let's stop. Let's let the numbers work themselves out. Let's spend some time talking about what they mean. All right, that's what statistics is all about. All right, because unless you're getting into all the origin stories behind the formulas, which is all based in calculus, what's the point of even getting into the numbers to begin with? Like, the number tells you something. What is that number? What is the meaning? What is the true meaning of that number? That's what we're after. Right? This graph is going to tell us something. It's going to tell us something really important about this data set once I tell you where this data set came from. All right, I'm going to give you a little context, and then you'll know everything you need to know about this data set based off of just this graph. All right? So, Now we just got to create the graph. Well, we know what it looks like. Big old middle finger. So let's just, every time I make a history, I make up random sets of data. All I look at it, every time I look at it, it's like the graph, here's another graph flipping me the bird.
I think it's pointing at you.
Yeah, it's just, it's pointing at the sky, yeah. Yeah, but where's the thumb?
This is the
On the side, right? It's like, I can't get away from it. I don't know. All right, so we're going to create bins on the horizontal axis. Fancy term for line segments. 1, 2, 3, 4, 5, 6 of them. So 1, 2, 3, 4, 5, 6. Histograms occur over intervals, so the space in between the line segments are what's important here. All right, not the line segments themselves.
I did the lines kind of small, so do we definitely need to flip that?
Nah.
Or it doesn't matter?
Nah, I just did it for visual purposes. So I'm going to write my intervals in those bins. So 0 to less than 20, 20 to less than 40, 40 to less than 60, 60 to less than 80, 80 to less than 100, and 100 to less than 120. All right. The less than part's a little weird for some people, but if you really think about it, it should make sense. Handwriting is what handwriting is, so just try to make it look decent on your paper so that in a couple weeks you're not coming up to me saying, I understand everything, but where did that 420 come from? You know, like, I do the best I can, but it is what it is. That less than symbol is saying that we're getting close to that 20, but we're not getting there. All right? So this is saying 0 to 19.99999999999. Keep saying 9s till you run out of breath. All right? But you're not getting to 20. Once you hit 20, you're in the next interval. All right? That's what that less than symbol means. It takes all the guesswork out of it. All right? You know that you're not getting to 20 in that first interval. All right? So, labels. A statistical graph is not complete without appropriate labels. Good news is, I'm not too picky about what the labels are as long as they are some semblance of the correct labels. All right? They just got to be in the right neighborhood. So, here's an example. Int. Perfect. I know what you mean. All right, I don't think you mean interception. So we're good. All right, interrogative. No, you mean interval. So we got it. We got it all covered. Freak. If it's F-R-E-Q, yes. If it's the other one, then maybe not. I'll take F. In the past, people have incorrectly interpreted that as, okay, labels, as long as they're there, you don't care what they say. Got it. That's not what I said. Because I had a student come up to me, they got their test back. They had the bottom labeled as frequencies. The top labeled as intervals. You know, some abbreviation of that. You said I could put it wherever I want. Like, that's not what I said. That's why you lost the credit. All right? You have to have it in the right place. I don't care how you abbreviate it, but it has to be in the right place. All right? And the worst part is they had all this stuff right, the numbers right. They just called it frequency. So that was frustrating all around. All right? So we're going up to 8. No reason why you can't go by ones. If you're going by ones, you don't have to put the numbers. All right. The default is assumed to be 1 tick mark equals 1 unit. If you're going by something other than ones, you have to give me an indication. You don't have to label every tick mark, but label 1 or 2 of them. All right. Maybe you label the last one. Like if this were going up to 16 and you were going by 2s, just label the last one 16 so I know. All right. Or label the first one 2. It doesn't matter to me as long as you give me a measure of the scale somewhere. All right. You have to label each bin. Definitely, you can't skip any of them. You got to label interval frequency in some capacity, like I and F. I'll take. I don't like just something. Give me something. You don't have to title the graph. All right. I consider the question itself as the title for the graph. All right. If you were writing a report or something like that, then a project, you would title the graph just because that would make sense to do it in that context. But for my test quiz and things like that, you don't have to title the graph. So just give me some semblance of the frequency labels. And then all we're doing is making connected bars consistent with these numbers. All right. Short version, make it look like that. All right. We just did all that on the calculator. Why not take advantage of it? You know what it's supposed to look like? A little add-on, I throw the numbers inside. And I don't want to make it a blanket statement, because generally I would say, and I recommend you do that too. I recommend you do that, but not you. You, but not you. Definitely you, but not you. The idea being that it's not necessary for everyone. Because I've seen people turn in test papers where the graphs that they created by hand are better than anything that I've seen even on a computer. I scanned a couple of, I gotta dig it up. See if I can remember her name too. Soyette Frazier, I think. What's her name? I mean, the most lovely penmanship I've ever seen in my entire life.
So, even though my tube looks like it's close to the fruit, I wrote 2, you get the idea.
Boom. Exactly. That's the whole point of this. Because my 8, the height of my bar, I don't know, it could be 7.5. I mean, it's a frequency, so it's not, but it could be 7, it could be 8. The number inside trumps the height of the bar. As long as the height of the bar is somewhere in the neighborhood of where it's supposed to be, whatever number you put in there is what I'm crediting you as for the height of the bar. All right. But again, there's some people that can make a work of art. And if that's the case, you don't have to put the number inside.
Honestly, I find it easier when I put all the numbers from 1 to 8 on the frequencies.
Yeah, it just,
graphic better.
yeah, instead of counting every time. Yeah.
Yeah, because you know where to connect the line. I mean, everybody.
Yeah. Yeah, sometimes that extra step early on saves you some time down the line. Yeah, that's a good point. All right, so that's the frequency histogram. Now, the concept itself on the calculator, I mean, you look at it and say, well, I could have done that by hand. Like, I could have come up with these intervals, going by 20s and counting them up. Like, why do I have to go through all that on the calculator? Look at the numbers. I mean, if I were to give you a choice, are these clean numbers or not clean? You had to choose one or the other. You're going to come up with clean because the alternative is not clean. Okay, what's not clean? Decimals, disgusting decimals. I don't see any in there. These are relative. Hey, maybe some odd numbers in there, whatever. But they're not nasty numbers, right? And there isn't 1,000 of them either. All right. If you're going to conduct a study, real data analysis, you're not doing it with 20 data points. If you only do it with 20 data points and you publish an article, like, it's going to be critically panned. That's one thing. But then there's the other part of it where it's like, what did you conclude? You know, and who does it apply to, right? So 20 data points, yeah, sure you can do it by hand, but I'm thinking more globally here. I'm trying to give you something that you can apply in the real world. It's always the real world. All right. So I give you even on a test. I try not to do this, but let's say I gave you even 30, 20 to 30 isn't a big jump, but 30 disgusting decimals. Now it's just an eyesore. Like you're analyzing the data. It's not hard, but like it's easy to get crossed up. Now you're losing points not because you don't understand the concept, but because you're transposing numbers here and there, right? So the calculator saves you from that, and then by extension the computer. And in all honesty, I don't know how many of you have experience with Excel or Google Sheets. If you master this functionality on the graphic calculator, then you know Excel and Google Sheets, because this is basically that, but the light version. All right, so there's a lot going on here. So anyway, just a quick run through again. I just want to take it from the top, only because I didn't get it in the video before. So, and also, it's just a good idea, especially with this. So we typed in the data. I'm going to take that part for granted. Originally, this plot was off. I turned it on. So I did that by hitting enter, and then hitting enter again on the word on. If this is the only math class you're taking, then you could just leave it on, because we'll be in and out of this menu for the whole semester. All right? If you're taking a different math class, like something involving functions, like pre-calc or college algebra or something like that, calculus, anything that would involve creating an ordinary graph like y equals x squared or something, then you'll want to turn this off at some point. All right, turning it off is very easy. Scroll to off and hit enter. All right, so we want it on. We're working with a histogram, so I hit the down arrow. I go over to the one that looks like a histogram. Now we know what that looks like. Hit enter. Now it's on. This is the default. If it's a frequency histogram, as in you were given a frequency table, then you would make use of this. But generally speaking, that's not what I'm going to assess you on. All right? I'm not going to give you the frequency table and then just tell you to make a graph out of it. Part of the challenge is coming up with the table itself. So you could probably take it on faith that this is not changing. All right, so if you don't scroll down into this area, you could just hit zoom 9. But if you do scroll down into that area, you see that the alpha lock comes on, which is incredibly annoying. Hit alpha to get that off. Then hit zoom. Scroll down. Find option 9 and hit enter, or just hit zoom followed by the number 9. It brings up the graph. Quality control. Go into your window. Take a quick look. Make sure these numbers make sense based on the data. 0 to 120 surrounds all the data points. The lowest value in my set is 0. The highest is 100. So 0 to 120 will cover that. It's going by 20s. Nice round number, so we're good there. Go back to the graph. Hit trace. These are your intervals. 0 to less than 120. There's 2 of them. Hit the right arrow until you get them all. And then that gets reproduced on the graph, and there you have it. All right, a lot of steps, but you're replacing thinking steps with mechanical steps. All right, sometimes we don't want to do that, but it's not a terrible trade-off. So the next type of graph, and then after this we'll take a little break. This one's a lot quicker because it's based off of this graph. All right, so we don't need the calculator for this, although there is a calculator technique. I just don't think you're going to find value in it. All right, so.
Should we clear our data, or we just?
No, just leave it in, because we're going to need it for Boxplots anyway. Okay. So we're going to work off of this data set and create what are known as cumulative intervals and cumulative frequencies. I always go back and forth. It's right here. I don't think I need the 4-column table. That's.
So the second one doing is Boxplot.
On the next page, we're going to do a box plot. Right now, we're doing a cumulative frequency histogram. Yeah, so I'm just going to make this a 2-column table again. Sorry, I know you don't have whiteout, but just write smaller, go over the line. This is how I had it originally, and then I changed it thinking this would be better, and it's just not. All right, so the first one is going to be the cumulative. I'm definitely not fitting that word in there, so I'm just going to abbreviate it C interval. And then cumulative frequency. All right. So with this graph, the name of the game is accumulation. We're trying to accumulate intervals, and we're also going to accumulate frequencies. All right. So it's kind of a weird thing to think about, especially when it applies to the intervals itself. But what we're going to do is we're going to work interval by interval and say, all right, and actually, the best way to visualize this would be if I were to take strips of paper, and each strip of paper had the interval with the corresponding frequency. All right, so 0 to less than 20 with 2 on one strip of paper, then 20 to less than 40 with a 1 on another strip of paper. All right, so if I go down and I just collect pieces of paper, the first paper I would take would be the 0 to less than 20 with the 2. All right, that's my first collected interval. So you could probably replace in your mind cumulative with collection. So instead of cumulative intervals, a collection of intervals. So we're collecting the first interval. All right. So 0 to less than 20. There's 2 of them. Now, we have the first interval already. All right, we had our little grab bag of intervals. We picked up the first one.
So is the C stands for cumulative or collective?
So the word C stands for cumulative. You can replace it in your mind with collected. Okay, yeah, so I just lost myself for a second there. So you have one collected interval, which is the 0 to less than 20 with 2 values. All right? So you already have that in your possession. Now we're going to collect the second interval. All right? So in our possession, so I'm going to do this. In our possession, we have these 2 intervals. All right? Now, I need to condense that into one row of my new table. I don't want to write 0 to less than 20, and also, by the way, now I have 20 to less than 40. What I can say is, well, if I have 0 to less than 20, and I also have 20 to less than 40, don't I really just have 0 to less than 40? I got them all together. So my next interval is going to be 0 to less than 40. That's not a pen. And when I collect the frequencies, I started off with 2. I collected my new interval, which gained me an additional frequency. Now I have a total of 3. All right? So I started off with the first interval, and it had 2 values. In addition to that, I now have the second interval with 1 more value. So if I put the 2 intervals together, it gives me 0 to 40, that's my interval of values, and I have a total of 3 values altogether.
So in other words, collectively, you have 3.
Exactly. Right. So then if I include the 40 to less than 60 with that original set, so I already have in my possession, I already have a 0 to less than 20, a 20 to less than 40. Now I'm going to include a 40 to less than 60, 0 to less than 60, exactly. And that's 7. All right. Now, once you get a sense of the trend, you really never have to do that again, because what's happening here is, and I don't like removing the thinking from this, because then you lose a sense of what a cumulative frequency histogram is telling you. But in terms of just quickly getting the table, what you're doing is you're just going from the lowest value in your intervals, in your set of intervals, which is 0, and you're making that the low end in every interval. So you're replacing the low value in each of the intervals with 0. All right? And then you're just taking a running total of all the frequencies. So 2 was our first value, add the 1 gives you the 3, add 4 gives you the 7, add 3 more, you'll get 10, and so on. All right? So there's shortcuts and everything. You can get it, but you don't want to sacrifice the learning in the process. So 0 to less than 80. I almost wrote 80. I mean, I definitely more than almost wrote 80. I totally wrote it. That should be 10. Zero to less than 100. So we're up to 18. And 0 to less than 120. And that'll get us up to 20. All right. The last entry in your cumulative frequency table should be the same as the total number of values in the set. All right, we got 20 values. That last entry should be a 20. If it's not, then there's a mistake somewhere. All right. Unfortunately, that mistake, if you come up with something less than other than 20, that mistake could be here, which would really suck, because we came up with this to come up with that, to then come up with this. You might have to do all this over again. So you want to make sure that this is good to go before you start moving on to anything else. All right, because a lot of things are dependent on that frequency histogram, frequency table, I mean to say. So let me get rid of that stray mark, because somebody's going to ask where that 0.2 came from at some point. All right, so then we just need to make a graph out of this. The good news is, I mean, it's incredibly procedural. We're just going to do the same thing we did here, just with these values. All right, so the same number of bins, we're going to write them differently, we're going to label them differently, and the frequencies are going to go higher, but it's going to be the same general structure, same concept. Three, 4, 5, 6. 0 to less than 20. 20 to less than 40. 40 to less than 60. 60 to less than 80. 80 to less than 100. 100 to less than 120. So cumulative intervals, and then cumulative frequencies. I mean, I suppose we can go by ones and get up to 20. I just don't particularly want to. So I'll go by fives. For this kind of graph, it's incredibly important that you put the numbers in. Where the frequency histogram, it didn't matter because the tick marks were generally aligned fairly well. Here, there's estimation involved, so we want to be a little bit more careful. All right, so, and also it gives you a license to rush through it and not really care too much. So, I have no idea if that's where 3 is, and I honestly have lost interest. So, that looks, I've got all the hallmarks of a 7, so that feels good. I don't know, it feels 10-like. It's in the neighborhood of 18 and right on up to 20. Yeah, beautiful. Look at that crappy drawing. A crappy drawing that's 100% correct gets full credit on a test. That's the point.